Hi, my name is Shigupta Khan, and this animation is about finding the relationship between voltage and current in a pure resistor AC circuit or a pure capacitor circuit and an inductor circuit. So first of all, we will look at a resistor only circuit. So that's the resistor. This is an AC supply. There's an ammeter in series that's measuring the current in the circuit. And this is a voltmeter, and it's a centered voltmeter. So if current is flowing in one direction, voltage will be positive or it will be negative. So let's start it and look at the relationship between voltage and current. So as you can see from here, current is changing direction. It's going back and forth, or it is quite obvious from the needle of the ammeter or the needle of the voltmeter. Now this is the voltage and current time graph. And as you can see from this one, that when the voltage is maximum, current is maximum, or we can say that voltage and current are always in phase in a AC resistor circuit. Now this diagram over here, these are showing the phases, or these are called vectors. So the blue one is for the voltage and the red one is for the current. And so the value of the voltage and current is constantly changing as these phases are moving along. And this shows the maximum value. And these two are in phase with one another. So let's change it to now a capacitor circuit. Reset and capacitor. So now let's see, start it. As you can see over here, current is again moving back and forth, but from the graph, it is quite obvious that voltage and current values are not in phase. These stars over here, they're showing the voltage and current values at different points in time. So if we look carefully, then red one is the current, and the blue graph is the voltage time graph, and they are not in phase. And it's quite obvious that current is leading, or the voltage across the capacitor is lagging, and it's lagging behind by 90 degrees. Phasors also show that. If I just pause it somewhere over here, okay, not exactly, but when this one was over here, this blue phasor was over here, and we can see there's a 90 degrees difference, and they're moving in an anti-clockwise direction. So the voltage across the capacitor is 90 degrees behind the current. And what is the reason for that? So the blue one is the voltage time graph. So that's where the capacitor has got maximum voltage because it is fully charged, or it has got the maximum charge. Now the current is the rate of change of voltage, and over here, or the gradient of the graph. So the gradient over here is almost flat. Therefore, the current is zero at this particular instant. But at this point over here, the gradient of this graph is maximum and it is positive. So voltage at this instant is positive. Somewhere over here, as we can see that the gradient is maximum, but it is negative maximum. So the current is zero. Or in other words, let's restart, resume it. Or what we can see is that voltage across the capacitor is 90 degrees, or it lags by 90 degrees as compared to the current. Now let's change it to the inductor. So now we've got an inductor in the circuit, and we will look at the relationship again between voltage and current. So let's start it. These dots show you the position, or these needles also show us when the current is maximum. So here current is maximum, negative maximum, zero, positive maximum, and so are the voltage values. The graph looks like this one. These are the phasors. So from the graph or from the phasor, we can see that this is current and voltage across the inductor. They're not in phase, and voltage across the inductor is ahead of the current by 90 degrees. And what's the reason for that is that voltage is only induced across the inductor when the current is changing, or when current changes at the maximum rate, then the voltage will be maximum. So if we look at the current graph, so here current is 0, but the rate of change of current is maximum, and therefore voltage is maximum, VL is maximum. Somewhere over here, rate of change, current is maximum, but rate of change of current is almost a flat line. So therefore, gradient is 0, or at this instant, the voltage across the inductor is 0. Or somewhere over here at this particular time, the current is 0, but the gradient is maximum, and it's a negative maximum. So therefore, there is a negative voltage across the inductor. So what we can say from here is that current and voltage across the inductor, they're not in phase. Voltage across the inductor is 90 degrees ahead of the current in the circuit. So that's all for today's video.